All right, so I'm Tony Vasile from Signiant, and today I'm going to give two demos. The first demo is a demonstration of the RESTful interface for a transfer service for the FIMS standard. And the second demo is a AS-11 asset validation in accordance with the DPP that you have to comply to deliver assets to the BBC and other companies. So first off, just a bit of background. I've been involved with the FIMS working group for approximately 3 years, and we've been personally involved with defining FIMS 1.1 specification, updates to the schema, and work on the RESTful interface for FIMS. So FIMS currently, as part of the standard in 107, had basically a SOAP and XML based interface defined by the committee. And RESTful interfaces have become quite popular in the last couple of years. And so what we did is we wanted to provide a SOAP-based option for the interface and a RESTful-based option for the interface. So I'm only going to really demonstrate the RESTful base for the transfer service, but all the different services have basically the same pattern. So what we've done is we defined that the payloads in JSON, or they could be in XML as well, but we figured most people using the RESTful interface would actually use a JSON-based interface. And we defined the URIs that you would use as an implementer of a RESTful interface, or somebody using services that have published a RESTful interface. So I just wanted to show an example first off of the current documentation that we developed for FIMS 1.1. So this is generated by the schema definitions themselves, but as you'll see in here, we also have augmented that with the corresponding RESTful interface that you would call on this as opposed to SOAP. So for example here, this one is for the transfer media, the create job service. Now the transform and capture have all the same patterns, so it'll be very similar. So the operation here is really, you want to create a transfer job. Description, it's a post, so it's a HTTP or HTTPS post method. The URI is going to be /job, so it's a relative URI, so your RESTful interface /job. And then the request body would be the standard definition for a transfer job type. And the response appropriately would be the success body, which would be your job coming back to your endpoint with the created body of the job, or a failure job type. So all of the corresponding, well, not all of them, but the majority of the corresponding SOAP endpoint interfaces have been mapped over to REST in this manner. And if we go back to a larger description here, if I look at the media status, again, you'll get a lot of details here on the different services that were available in SOAP, and they're really now just RESTful endpoints that we've modeled. So for example, retrieving a job, you just /job and the job ID that you've specified when you submitted the job. Retrieve all jobs, which is all just basically standard RESTful type patterns that you would use when defining a RESTful service. And then we've encapsulated as well managing a job. So if you want to cancel a job, set priority, start the job, for example, all of this can be done with the RESTful interface. So I won't go through all of these now because it's fairly self-explanatory when you read the documentation. What I'll show you now is an example of submitting a transfer job to our Signiant product that has basically implemented the RESTful interface for the FIMS transfer service. So if I go over to SOAP UI, so SOAP UI is an open source tool that you can get, and it actually can generate SOAP and REST-based messages. So we use this quite a bit. Pardon me? Yes, it does both, right? And it'll actually transform the payload from XML to SOAP interactively. But what I'm going to start off with is the create job. So I'll open up a create job request just to show you what it looks like. And this is a very simple job here, and hopefully we can see it. Right. But in a sample create, so that the resource method is going to be a post, and it's just our relative path to our service, transfer service, and then /job. So this is actually going to ask Signiant service to create the job. So as you can see, the all of the information here for the standard specification is represented in JSON as opposed to XML. But the fields are actually the same field names, so the attribute names are the same. Arrays of information would be represented in a JSON format. And the same values, for example, priority, finish before, and an important one here is the reply to. So you can specify as part of the FIMS interface, when you submit a job, you want to get asynchronous responses for that job, because one of the benefits, or in the design of the FIMS interface, was designed around long-running processes. So transferring large media files, for example, in the case of the Signiant product, transforming, so running transformations on media, these are all long-running. So what you don't want to have is a system that polls or waits, because the wait can be quite a long time. So you want to submit the job and have an asynchronous method that calls you back with state transitions of that job. And that's exactly what the FIMS interface was designed to do. As well, you specify a resource ID. Now the resource ID is a globally unique ID that's specific to your job request. And the idea there is that you're going to take this ID and you're going to use it in a chain of different components, calling out to say, first off, transfer the asset, transcode the asset, ingest the asset into a media asset management system. And you want to use the resource ID that you've represented the job as, right? So then you can actually have that same ID tracked throughout the whole system. And then each component you call that has a RESTful interface, then you can track it easily. And you'll see when the job comes back that a vendor can track the job internally into their system by having the service vendor ID. So it allows you to track it with your ID, but then I can track in say, for example, the Signiant manager job, the job internally the way that I would track it with my ID. So that's a useful thing as well, because it allows you then to correlate the job in the system with the job in the workflow that you're orchestrating. And then over here we have the BM contents, and these are all really just objects. I won't go into details of what they are, but it specifies the payload. So for example, the essence locator is really, the essence is, what is it? What's the asset we're working on? And so we specified an essence locator here of a simple file type locator. So you can have simple file types, list file types, and I think folder file types as well. There's 3 of them. And what we specify here is just a URI. So for example, where is this file? So any valid URI could be used here to specify the location of the file. Now here we happen to specify, an agent. In our system, Signiant agents transfer data between each other. So we specify an agent there, part of the URI, and the actual source, which would be the files to transfer, and tell it's a simple file locator type. And then as well, you have basically the transfer profile. So the profile basically just specifies in the case, what do I do? How do I operate on this data when I receive it? So a transform profile is quite extensive. A transfer profile is not, because it's really just, okay, when you get this, really what we want to know, where do I send this data to? So I receive it from one system, I'm going to send it to another system. And again, it's basically a URI. So you could specify, I'm demonstrating this with the Signiant product that accelerates the data, but you could specify as well in the URIs here, FTP, HTTP. So it's an open standard, so it should be consumable by anyone who implements the standard properly, right? So what I'll do is just go back to, just for one moment, I'll go back to the Signiant, the dashboard, because I'm going to show, for example, here, the job being submitted. So that's one I did earlier. I'm just going to delete that job. And I'm going to demonstrate for the use case here, we're going to submit a job into the Signiant system, and we're going to show the concept of the queuing that's built into the FIMS framework. So FIMS supports various job states, so running, paused, resume, and queued as well. And I think there's failed, there's complete, but queued is an important concept, because a lot of times when you're submitting jobs, in an automated fashion to a system, that system may have to throttle the number of active things it's doing at a particular time. So again, using the Signiant system as an example of that, we've got a system that allows you to actually enforce SLAs automatically within the system. So for example, job submitted over a specified link, so from say one destination to the other, you may not want to oversaturate that with too many jobs. So we have job queuing in there so that you can automatically provision a bandwidth with that and not oversubscribe your link. So when I submit the job to the system, now this is going off to the Signiant manager that's implemented the REST interface. I'll submit that job, and when I get back, the response, oh, sorry. No, the job already has an ID. The specified ID is existing. Let me try that again. No, I gotta, whoops. Let me go back here and see. The job IDs have to be unique, and so the script we have generates brand new jobs, the IDs all the time, but it looks like it didn't work. But let me just go back here. And I might have to give it a unique job ID here, so I'll just go back and say the resource ID will be I'll cheat a bit. All right. I'll just have to remember I've copied 6 9s in there, so let me resubmit this job. Right, so great. So I've resubmitted the job. Now what I get back from here is the JSON response to say the job has been successfully submitted, but here's my service provider job ID, right? So that's how the Signiant system's representing the job, my resource ID, and the status is queued on the job. So you can send back as part of the specification the full job payload or just the minimal attributes. And we've specified the minimal attributes for minimizing the amount of data going back and forth, and the user can always do a get on that job ID and get the full the job representation. So when the job gets submitted to the system, now we see the job has been queued. So we're representing the priority specified in the FIMS job. So we specified all these as low priority jobs coming in, the FIMS jobs, and there's 2 jobs ahead of it running. So when I go back now to the other job definition that I have, this is a managed job request, and what I want to do now is programmatically have that job give it a higher priority than the existing jobs that are queued. So what I can do here now, we'll have to cheat again. Save that one. So if we can see that. So now I'm going to go and I'm going to give that job the high priority. So it'll move it up to the head of the queue. So I'll run this one. And it comes back again, JSON format saying it's still queued, but it's been moved to the head of the queue. And if I go back into the management console here, I see now it's queued 1 of 3 as opposed to the 3 of 3 jobs. So it's moved it up to the head. So it'll now be executed next in sequence, and that's how you can prioritize the jobs. You can also specify as part of the specification immediate, which means stop everything else and run it now, but I've just specified moving it up. And then as a last example in the interface, I can actually now just go and cancel that job. So if I go here, the cancel, I can now decide that that job actually wasn't a priority, and I'll submit a cancel to the job, and the job response comes back to me as canceled. But also, if you look down here, I think it's here. sorry. Getting a bit lost with all the, so I wanted to show you, oh sorry, here it is. In the script log, these are the responses I'm getting back. It's not formatted very nicely in this tool, but these are the asynchronous responses I'm getting back from the actual Signiant system, asynchronously telling me about the state events of these jobs. So the job was queued, the job actually went to running when I moved it up, and then when I finished, I submitted the job and basically it got canceled, right? So it came back as canceled. So that's the essence of basically a quick demo of showing the RESTful implementation of a service. In all the other services that are defined here, so transfer, transform, capture, they all follow the same paradigm, the same set of basically endpoints, that they would just be different actual endpoints. And the repository service, which is new in 1.1 as well, that service actually has a bit different pattern because dealing with the media asset management system is a lot more complex, but it does have a specified RESTful interface as well that you can accomplish all the operations you could using SOAP and XML with REST and JSON payload. Right. And if I just go back here, we'll see that job that I submitted the cancel for got canceled. So that's the FIMS REST interface portion of the demo that I had. And does anyone have questions? No? Has anyone implemented REST or thinking about implementing REST? Or sorry, FIMS?
Thinking.
Right, about FIMS, yeah. For which service?
Well, we run Signiant.
Oh, you do? Okay.
So I will sort you afterwards.
Right, sure, yeah, not a problem. Because you can use REST, from our transfer as an engine, we can be driven by REST, but also our workflow canvas, we can call out to other services using the RESTful interface as well, right? So it's we have both because we're kind of a hybrid. We have workflow engine, but then a lot of customers drive us in their workflow engines as well. So quite powerful. So right. So again, I think the 1.1 documentation is almost ready. There's a website as well that has been made available that you can go and research any information you need about FIMS and REST, and clearly, anyone who has questions, I can give them a card after, because I've been quite active in the REST technical board, so I can answer some questions. So now we're going to talk about a problem that is pretty prevalent, dominant in the media industry, is validating assets. So as a consumer of assets that your customers may be sending you, or contractors may be sending you, you want to validate that the content is actually in the right format, conforms to the right specification and whatnot. And we've heard from customers, and I don't know if others can collaborate this statement, that up to 20% of content they receive from their customers is not in the right format. So the problem with that is that actually now introduces a delay, because now you've got to contact the supplier, tell them this is not in the right format, the supplier has to regenerate and then re-upload the content to you, and that whole process could take hours or days to have that whole loop. So in accordance with the DPP, we've implemented a service, and it's really inspecting MXF, and I know there's a lot of work going on with MXF and EBU, for example, that basically will pre-validate content before it gets ingested into a system. And the difference between that, between a traditional full QC to do that, is that the full QC typically needs the entire file. So what we've done is we've done a light validation, is we've just pulled out the MXF headers and the other information associated with the headers to validate that before the customer would actually upload the content into the system. So we can at least tell the person that, hey, this is not the right format that this customer wants to receive the data. So that spends saves a lot of time in the whole turnaround process. Now the validation typically still has to be done when it gets uploaded, like a deep inspection full QC, but at least they're not sending you something right away that's going to fail. So for example, it's not HD format, for example. So we have various products, and I'll show you one with our Media Shuttle product, where it's an end user system that accelerates upload of content into your system. And with this product, you can actually specify a filter, so our compliance that says we only want to receive content of this particular type. So when a user would go to this portal, for example, and they would say, okay, I want to upload to customer X who's bought this product and is running this portal, I can specify the metadata that I want to examine before the content gets uploaded. And that's called, in our product, it's the asset compliance. So if I click on this here, in the interface here I say, oh, files must conform to MXF, single file, UK, DPP, HD. So the person who's set up this portal, Media Shuttle portal, they only want one file uploaded from the customer, and it's got to be HD DPP compliant. So if the customer is looking at this going, what does that mean? They can click on this, and it actually tells them exactly what it means, and you can actually see and display the required attributes for the asset that the consumer wants to receive. So you can specify the video format, and this is all done with AS-11, so whatever that standard is, we show it to a person creating the asset, and the asset has to conform. Now, if the customer then wants to go and upload content, if I look at content here, I'm going to purposely pick a content that doesn't conform. So the customer's now saying, okay, great, I've got this content, I've selected it, I'm going to upload. So we do the transfer. Before we even transfer the data, we validate the file. And now this is all running on the local system of the producer, not on the consumer system. And what we do again is we read the metadata out, send it to our asset compliance service that is cloud-based, and inspect that metadata and report back what's missing. So if I look here, I said, oh, that failed. So I'm the customer saying, well, why did it fail? Click there for details, and now it actually gives you, this is what we expected as part of that asset, and this is what was actually there. So the person using the system can actually see, okay, this is what I did wrong. In this case, I picked the wrong file, but maybe I didn't generate it in the right format or at the right bandwidth, for example. So it's a very powerful system that uses MXF standard to enforce to enforce compliance from customers uploading to consumers. And you can specify different formats as well when we're talking about the actual Media Shuttle product, but talking generals in MXF, we have support for the HD, and you can specify other formats as well. Yeah. So,
if you have a Signiant partner, you're trusted, you can use the same.
yes, yeah, because getting back to product, the Signiant Manager and Agent product, this same functionality is available there in a workflow as well. So if you're going to send content out to customers or you receive content, you can run the asset compliance on it and then automatically alert them that this content is not correct before you even ingest the content into your system.
So if they're putting it into a hot folder on an agent somewhere else, how do they get the notification back that can be through an email?
Yeah, that's right. Yeah, you could set up an email to the partner that says, oh, this hasn't complied to what I want, and you email them back, and then they can take corrective action.
What was the name of the function?
Pardon me?
The name of the function?
It's called asset compliance. And if anyone wants information on that particular implementation that we have, you can come to our booth and talk to the product manager. But we wanted to demonstrate here how we're working with standards, MXF, and using that to help out media companies just hit SLAs in a more timely manner.
You do an AS-11 or you do more?
Well, right now we have AS-11, but this is extensible to do other formats as well, right? And you can even do, say, just file format. I only want MP4s. I only want JPEGs. I only want 3 of this and 1 of that. XML sidecar. So you can set it up. It's quite extensible. So. it's not just MXF inspection, it's others too, but for the standard, it's the MXF. Whoops. Okay, so that's all I have for today. Anyone have questions?
Back on your FIMS implementation for
Yes.
workflow,
Yes.
is that available today in your product that you ship?
Yes.
It's
Yeah, that's right. We've had it available for about maybe a year and a half.
So that's FIMS 1.1.
Yeah. Well, we have now. Yeah. Yeah.
Because it was implemented at the time of FIMS 1.0. It's also in FIMS 1.1.
Yeah, that's right. Yeah.
So everything you've done there is in FIMS 1.0.
Yeah. So we have 107, and then and all this is available now. 1.1 is just carried forward to 107, right? There's a couple of structural changes with the schema, very few, and the rest URIs are now standard, and the payloads are standard, and then there's a repository service that's available now too.